Hello students, good morning all of you. This is your Prabhakar. Welcome to my channel Dawn of Chemistry. Hope you are all happy and healthy in your homes. And in this video, I am going to discuss about the topic hybridization. What is hybridization? How many types of hybridizations are there? What are the different molecules with different hybridizations? Which kind of orbitals are involved in which kind of hybridization? And very much important topic, shortcut to identify the hybridization in any molecule. Let them give any molecule, let them give how to find the hybridization of the particular central atom in that molecule. Right, by the way, let's get into the topic hybridization. See, basically in chemical bonding we study about the ionic bond, covalent bond and then coordinate covalent bond. Ionic bond will not come under this hybridization concept. No ionic compound will be having this hybridization. There is a different theory for ionic compounds that will explain the properties of all ionic compounds. So there is no relation of that thing with here. And next you see covalent compounds. Mostly covalent compounds. What is the hybridization of sodium in NaCl? Means it's not possible to identify like that one because that is a ionic compound. Here only for covalent compounds only this hybridization topic is involved. To explain the properties of covalent compounds, valency bond theory is proposed and then hybridization concept is proposed and then Vesper theory is proposed. All the three theories will be applicable for the covalent compounds itself. Let's get into the details. Hybridization. You see, 30% of inorganic questions will be having relation with chemical bonding and then periodic classification. Basically, every student are really worried about the inorganic chemistry because it is mostly based on the memory topic. So I may not be doing well in the inorganic chemistry like that. Everybody will be so much worried about this. Don't worry about the inorganic chemistry. There are some specific concepts are there and specific approach is there. If you can approach in that manner, means easily you can score the nearly 80% of the inorganic questions that comes in your entrance test, and that is in very easy manner also. Of them, one major approach is chemical bonding and then periodic classification approach. If you are strong in the chemical bonding, if you are strong in the periodic classification, definitely you can answer the 33% questions of the inorganic chemistry. They are purely based on this chemical bonding and then periodic classification. And of the inorganic questions, definitely 10% of questions will be based on this hybridization. You can expect 10% questions based on this hybridization concept. So why to wait? Let's dwell into the topic. Okay, hybridization. See the definition of hybridization. But here I am not directly going into the concept. So from foundation onwards I will be coming. So first we will see what is hybridization, how many types of hybridizations are there, and what are the properties of different hybridizations, and after that how to find the hybridization of a molecule and how to find the bond pairs and how to find the lone pairs in a molecule also. Let us see the phenomena of mixing of atomic orbitals to form same number of orbitals that are having better properties than atomic orbitals is called hybridization, and the orbitals are called hybrid orbitals. So see, the phenomena of mixing of atomic orbitals to form the same number of orbitals that are having better properties, that are with better properties than atomic orbitals, is called hybridization, and the phenomena and the orbitals are called the hybrid orbitals. Let us see, we are having mangoes are there. In olden days, the mangoes are with lower properties, like nowadays we are having big mangoes with sweet taste, but olden days it is like if a big mango is there, it will be sour to taste. If a small mango is there, it is very sweet to taste. So whenever there are different plants are there, they will take the different plants and they will hybridize them, and they will get a hybrid plant which will be having the large mangoes with sweet taste. So that means the hybridization is a phenomena which will produce a better yield, or better products will be coming. If you see this atomic orbitals, by using the atomic orbitals concept, we can't explain the structure of molecules, bond angles, and the strength of bonds between them also. That's why, to overcome that deficiency, the hybridization concept is proposed. According to hybridization, whatever the atomic orbitals are present in a compound, those atomic orbitals will combine with one another and they will be producing the hybrid orbitals. These hybrid orbitals will form the better bonds and they will be arranging properly in a direction, so it will get a specific shape. You know well, ionic bond is a non-directional and covalent bond is a directional bond. See, always sigma bonds formed by hybrid orbitals. Always sigma bonds are formed by the hybrid orbitals. Let us see how many types of hybridizations are there, what are the properties of them. The different hybridizations are sp hybridization, sp2 hybridization, sp3 hybridization, dsp2 hybridization, sp3d hybridization, dsp3 hybridization, sp3d2 hybridization, d2sp3 hybridization, and then sp3d3 hybridization. This much we will be having in our syllabus, even for our things also, but more than that also possible, but that are not necessary for us. So listen carefully. sp hybridization means one s orbital and one p orbital will combine with one another. One s orbital and one p orbitals form two sp hybrid orbitals. So 1s and 1p will combine to produce 2 sp hybrid orbitals. Here it will produce 3 sp2, 4 sp3, 4 dsp2. Here 5 sp3d. Here 5 dsp3. Here it will be 6 sp3 d2, 6 d2 sp3, 7 sp3 d3 will come. These are the hybrid orbitals. If you look at the shape of the molecule is linear. Linear means central atom will be like this and this will be like this. This one will be trigonal planar. Trigonal planar. This one will be tetrahedral. So trigonal planar means A will be like this and the compound will be like this, and tetrahedral means this will be the structure. This will be square planar. Square planar means A will be like this and 4 corners 4 will be present. sp3d is there. Trigonal bipyramidal. A will be here, B, B, B. Top one B will be there and bottom one B will be there. dsp3. dsp3 also will be same only. Trigonal bipyramidal. So same will be coming. sp3d2 will be octahedral. Octahedral means A will be in the center, B will be in the corners above the plane, and I will show you the structures also how they will be coming. Here also same. Here it will be pentagonal by pyramidal will come. So A, B, 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 above one B will be there and below one B will be present. So if you observe this thing here, in the first case you see sp hybrid orbital, one s orbital and one p orbital are combining with one another to produce sp hybridization. So in sp2, how much s and how much p is there means percentage of s and percentage of p. sp, only one s and one p is there. So in the two orbitals, one is s and one is p. So s character will be 50%, p character will be 50%. In sp2 hybridization, among the three orbitals, one is s, two is p. So that is 1 by 3 means 33.33%, 66.67% will come. sp3 hybrid orbitals, 1 in 4. So that's why 25% and 75%. Here you see dsp2 is there. S character will be 25%, 50% of P and 25% D will be there. Simply here. Total orbitals are 4, S orbital is 1. So 1 by 4 into 100, D also 1 by 4 into 100, 2 by 4 into 100 will come. In this case you see 1 by 5 into 100, percentage of S, percentage of P, percentage of D. So 20, 60, 20. Here also 20, 60, 20. sp3 d2, 1 by 6 is there. You know what will be the 1 by 6 value? P orbital will be 50% will be coming. So 1 by 6 into 100. 16.67% will come, and this will be 23.33% will come. Here also same thing, 16.67%, 50%, 23.33%. sp3d3 is 1 by 7 into 100 will come. 1 by 7 into 100 means this will be 7 ones, 14.3%. In this 14.3, this is 3 are there, this is, so 3 by 7 into 100 and 3 by 7 into 100. So it will become 38.35%, 38.35%. So be careful with this thing. How to find the percentage of the particular orbital. So sp hybridization means S character is 50 and P character is 50. How can we find this? 50% means, listen carefully, S character will be sp, two sp orbitals are there. In the two orbitals, one is s and one is p. So 1 by 2 into 100. Here 1 by 3 into 100, 1 by 4 into 100, 1 by 4 into 100, 1 by 5 into 100, 1 by 6 into 100 and 1 by 7 into 100 will come. Like this we can have the different examples. One more is there, that is bond angles. So listen carefully. In this linear, the bond angle is 180 degrees, this one will be 120 degrees, and this case 109 degrees, 28 minutes. Square planar 90 degrees will come. In this case, in between 120 degrees and then 90 degrees will be there. 90 degrees, same 120 degrees and then 90 degrees will come. In this case 90 degrees, 90 degrees, and in this case 72 degrees and then 90 degrees will be coming. So like this we can have the number of examples for this hybridization. So how can we identify this different hybridizations and how can we imagine in a three-dimensional space? So in a three-dimensional space, to understand these structures, first we should be having idea on the what are the trigonal planar structures, what are trigonal pyramidal structures, and what are the pentagonal structure. So let me tell you this. I will try to give you a brief idea about this thing by showing you different structures. You can see this thing and you can understand better. Here I will show you the rough diagrams. These diagrams may not be exactly like triangles and others because I am doing this roughly in the class itself. So it will be little difficult for me. So I will try to explain you in a maximum possible way that I can do now. So let us see. So let us take an example for linear. When you take a linear thing, if you take this is one molecule and this is one molecule and my hand is the central atom. When central atom undergo sp hybridization, it will form, this is one sp orbital, sp hybrid orbital, and this is one sp hybrid orbital. So central atom will form two sp hybrid orbitals and you can see the bond angle 180 degrees, and here one atom will combine and attack and here one atom will combine and attack. Sir, what are the examples? Means when I am explaining you the hybridization for different molecules, there I will provide everything to you people. Let's understand the structures in this. So my hand is the central atom and that is undergoing the sp hybridization. So this is one hybrid orbital and this is one hybrid orbital. So the bond angle will be 180 degrees. If it is undergoing sp2 hybridization, since it is undergoing sp2 hybridization, here you can have three orbitals are there. So here you see this is a triangle you can see. And the structure is planar also. Since the structure is planar and this is known as the sp2 hybridization, and trigonal planar we call this structure as. Why it is a trigonal planar structure? So this is the central atom, this one bond is there, this is one bond and this is one bond, and what will be the bond angle means 180 degrees will be coming. So that is for sp2 hybridization. Why bond angle is 120 means this. Next you see tetrahedral. Tetrahedral means bottom three will be there and above one orbital will be there. Like this you can have. So the central atom, my hand is central atom and that will be forming the hybrid orbitals. One hybrid orbital, two and then three, and this is one. So bottom one pyramid is there. You can see this looks like a pyramid for you people, and exactly above one more will be present. This is known as a tetrahedral structure. So like this you can understand. Sir, what is trigonal bipyramidal? So let me show you this. Trigonal bipyramidal means why it is called trigonal. So if you see this one, this is a triangle, right? And if you see this thing, the central atom. So exactly where I am piercing this, that point is the central atom, and imagine here. So here you see one atom will be on this corner, one atom will be on this corner, and another atom will be on this corner. So whenever you take this thing, one atom, two atom and three. So 1, 2, 3. Like a planar triangle you can have a structure. One atom will be above and one atom will be below. So why it is trigonal bipyramidal means this is a triangle base. You can have a pyramid like this, and bottom also you can have a pyramid will come. See, understanding this structure is very important. Why? Because whenever you are studying the Vesper theory, in the Vesper theory there is a lone pairs will be there and bond pairs will be there. What is the position of lone pair and then bond pair? For that purpose you need this example. So be careful with this thing. So here you see trigonal bipyramidal. Base is triangle, above one pyramid and then below one pyramid will come. That is trigonal bipyramidal. TBP we call it as. And you see next one is octahedral or square bipyramidal. If you see the base, here you see this is one thing you can have like this. So the central atom is present here. 4 atoms are present in the 4 corners. 1 atom, 2 atom, 3 atom and then 4 atom. Above 1 atom and then below 1 atom will be there. So like this we can have square is there. square bipyramidal. Above one pyramid and then below one pyramid will be present. In the same way, pentagonal bipyramidal. So in the pentagonal bipyramidal, so a pentagon will be there. Of course, this is not a proper pentagon. I just roughly removed that paper. That's why it came like that. So you see, this is a pentagon. 1, 2, 3, 4, 5 will be there. 5 atoms are in the 5 corners, above one atom and then below one atom. So like this, we can have the pentagonal bipyramidal structure will be coming. So now you see what is hybridization? SP, SP2, SP3, DSP2. What is a square planar means? This is the square planar. One atom will be here, 1, 2, 3 and then 4 will come. So like this you can understand this phenomena. If you see this DSP2 hybridization and then DSP3 and then D2sp3, we will study very well in case of the complex compounds. There inner orbital complexes are there and then outer orbital complexes will be coming. Whenever there is inner orbital complex, we will go for the inner d orbitals. 3d orbitals will participate. Outer orbital complexes means 4d orbitals will be participating in the reaction. When complexes thing I am preparing, that time I will give you very better example for that one. Or whenever we are doing examples, that time I will give you better examples. Right? So now understand this very clearly. What is hybridization? How many types of hybridizations are there? Why I am explaining these types of hybridization here only means, see the questions. So in sp3 hybridization, what is the bond angle? In sp2 hybridization, what is the bond angle? What is the structure of the molecule? What is the percentage of S character? What is the percentage of P character? That kind of questions they will give you. Or simply they will give you a series of molecules and they will ask you arrange the following in the increasing order of their bond angles, decreasing order of their bond angles, increasing order of percentage of S character and decreasing order of percentage of S character. Like that also they will be asking you. See one more thing, as the percentage of S character increases, because of the small size of the molecule, because of the small size of the S character, electronegativity is directly proportional to the, inversely proportional to the size. Size increases means electronegativity decreases, size decreases means electronegativity increases. So that's why, see, whenever we are doing problems, you have to see for the hybridization and percentage of S character. Percentage of S character increases, electronegativity automatically increases. That's why alkanes and alkynes, which are more acidic in nature, means alkynes. Because in alkynes sp hybridization is there, in alkenes sp2 is there, in alkanes sp3 is present. So that's why you have to definitely identify the percentage of S character and then you have to identify the acidic nature also. Be careful with that thing. So like this we can easily understand these concepts. Clear? Right. So that is the introduction of this hybridization. What is hybridization? How many types of hybridizations are possible and what are the percentage of S characters, what are the structures and what are the bond angles. Take down this for 2 minutes. Sorry for the things, I didn't observe this. DSP2 hybridization, 4 DSP2, 90 degrees, square planar and then 25, 50 and then 25% will come. I didn't observe that thing. Right, ma. Let us continue for the next thing. Sir, how can we identify what is the hybridization present in a particular molecule? Let me give you the examples and through the examples I will be explaining this concept in detail. Listen carefully, ma. This is the very most important topic. So let us see how to identify the hybridization. See, by using this trick, by using this formula, you can identify hybridization in any molecule within 20 seconds. You can do the problem. Let us get into the details. Number of hybrid orbitals is equals to half into V plus M minus C plus A. Let them give any species. There are two methods to identify the hybridization of any species. That is, for inorganic compounds, we will use this formula. For organic compounds, by finding the structure, we can identify. For inorganic compounds, let them give you anything, let them give you any species. By using this formula, number of hybrid orbitals is equals to half into V plus M minus C plus A. If number of hybrid orbitals is 2, it is sp. 3 means sp2, 4 means it will be sp3, 5 means it will be sp3d, 6 means it will be sp3d2, 7 means it will be sp3d3. Don't worry about the inner orbital complexes. For inner orbital complexes, in complexes thing, I will explain you a better example. Don't expect them to be inner orbital. Mostly by using this formula, whatever we calculate the hybridization, that will be always outer orbital complexes only. Let us see what is V. V is equals to number of valence electrons on central atom. Always remember, central atom will be only one in every molecule. So that's why the central atom will be always one, and that will be more electronegative always, not always, sometimes. Clear? Majorly it will be more electronegative atom compared to the other atom. V is number of valence electrons on central atom. M is equals to number of monovalent atoms surrounding central atom. Number of monovalent atoms surrounding central atom. Monovalent atoms means mostly they are halogens and hydrogens. Mostly these only will come. Halogens and then hydrogens only will be coming. C is equals to charge on cation and E is equals to charge on anion. If they give you anion, means you have to consider the charge on anion. If it is cation, means charge on the cation will be coming. So number of hybrid orbitals is equals to half into V plus M minus C plus A. By using this formula, we can find the hybridization in any compound. For inorganic or organic means inorganic compounds. Let us come to the organic case. If atom attached to single bond, the hybridization is sp3. If atom attached to 1 pi bond, the hybridization is sp2. If atom attached to 2 pi bonds, hybridization is sp3. This is for carbon. Whenever you take any organic compound, in the organic compound, if carbon is attached to single bonds, always means it is sp3. If atom is attached to 1 pi bond, means it is sp2. If atom is attached to 2 pi bonds, means it will be sp3. Hybridization will be coming. Remember this carefully. Let us get into the details. Even for oxygen also same thing. Even for sulfur also same thing. Let us see. CH3, CH2, CH double bond CH, C triple bond CH, CH3 C double bond O, CH2 CH double bond CH, C triple bond N, CH, CH2 OH, CH3 C double bond O, OH. So see, in the organic compound, listen to this very carefully, ma. Whenever they give you organic compound, for organic compound, how to identify the hybridization means. As this principle says, if atom is attached to a single bond means it is sp3 hybridization. If atom is attached to 1 pi bond means it is sp2 hybridization. If atom is attached to 2 pi bonds means it will be sp3 hybridization. You know very well how to write the structures of organic compounds also. Right, let us get into the details. Here you see this is having only one sigma bond attached, so it is sp3. This is also both sides single bonds, sp3. Here you see one pi bond is attached, so sp2. Here also sp2. Here you see 2 pi bonds, so sp. Here also 2 pi bonds, sp. This case sp3, sp2. Oxygen 1 pi bond is there, sp2, sp3, sp3. Here only sigma bonds are there. sp3, 1 pi bond is there, sp2, 1 pi bond, sp2, sp will come, nitrogen, say sp only. If any atom is attached to 1 pi bond means it will be sp2, 2 pi bonds means it will be sp will come. And finally come to this thing, CH3 is there, sp3, sp2, sp2, sp3. See this? CH3 C H double bond C double bond C H CH3. Now you see in this case what will be coming? sp3 sp2 because 1 pi bond. This side you see both sides 2 pi bonds are there, so sp sp3 like this. By using this logic, you can identify the hybridization of any carbon in organic case. This is very important when in organic chemistry, they will give you an organic compound and they will ask you indicate the hybridizations of the central atoms. And this is in your PU examinations also, the board examinations also, they will be asking you this kind of questions. What is the hybridization of the particular compound? So be careful with that. Let us get into the things. This is the main core for us. So how to identify hybridization in inorganic compounds? That is, number of hybrid orbitals is equals to half into V plus M minus C plus A. By using this thing you can identify. Now we will see the different examples for this. Take down this thing for 1 minute. Right. Now let us see the examples. Let us keep the formula there, because it helps to understand better. See, BeCl2, BeCl3, SiH4, PCl5, SF6, IF7, CO3 2 minus, SO4 2 minus, NH4 plus, CH3 plus, NO3 minus HYBR3. So these are the compounds we are having, and how to identify hybridization of these molecules. Right. Let us see. The first one, BeCl2. As I told you, central atom will be only one always. So whatever there is a single atom, that will be the central atom. So for example, if you take this compound, let us say FCl is there. Clear? What is central atom means? Fluorine will be. When there is a single diatomic molecules are there, in the diatomic molecule, the central atom will be the one which is with more electronegativity. Right. Be. The formula is what? Half into valence electrons. In beryllium, hydrogen, helium, lithium, beryllium. In beryllium, the valence electrons are 2 itself. So 2 plus 2 by 2. 2 plus 2 by 2 means 2. 2 is there means hybridization will be sp hybridization. BCl3. Hydrogen, helium, lithium, beryllium, boron. Boron is the third group member, so valence electrons are 3. So half into 3 plus 3. So that will be 3, and it is sp2 hybridization. SiH4. Silicon is fourth group, so 4 plus 4 by 2, 4. It is sp3. PCl5. There is no need to by heart at all. PCl5 in gas state is there, and in solid state it exists as PCl4 plus and then PCl6 minus. This is very important one. Underline this carefully. Direct NCERT statement it is. PCl5 in gas state, what is the structure of it, and PCl5 in solid state, what is the hybridization of this one. So let us see. PCl5 means what will come? 5 plus 5 by 2, 5. It is sp3d hybridization. PCl4 half 5 plus 4 minus 1 by 2. So 4 will come. Why minus 1? Minus C. If it is cation means its charge you have to subtract. If it is anion means its charge you have to add. This one half into 5 plus 6 plus 1 by 2. What will come? 6 will come. So 6 means sp3d2 hybridization and then sp3. Like this, there is no need to by heart anything. There is no need to by heart. Remember this formula, substitute this, and let them give you any compound from any corner of your NCERT, any corner of any reference book. You can use this formula and you can identify. SF6. 6 plus 6 by 2. So sp3d2 will come. IF7 half into 7 plus 7 by 2. So 7 is there. sp3d3. CO3 2 minus means 4. Oxygen, there is no valency, that is divalent atom, and there is no monovalent. Plus anion is there. 4 plus 2 by 2. So 3. It will be sp2. SO4 2 minus means 6 plus 2 by 2, 4. It will be sp3 hybridization. NH4 plus 5 plus 4 minus 1 by 2. Why 5 plus 4 minus 1 by 2? Because it is cation. So CH3 plus means 4 plus 3 minus 1 by 2. 4 plus 3, so it will be 3, and it is sp2 hybridization. NO3 minus means 5 plus 1 by 2, so it will be sp2 hybridization. IBr3, iodine is a central atom, so 7 plus 3 by 2, 5. It will be sp3d hybridization. FCl means 7 plus 1 by 2, 4. So it will be sp3 hybridization. Like that, let them give you any compound from any corner that is based on this inorganic chemistry. Let them give you ions, let them give you the substances. You can use the formula half into V plus M minus C plus A. You can easily identify the hybridization of the particular molecule. Is it clear, ma? Right. So let us see whatever is there. For that thing, you should be very careful about the hybridization. Simply they will give you BeCl2, BCl3, SiH4 and PCl5. Or only these three they will give you, and they will ask you arrange the following compounds in the increasing order of their bond angles, in increasing order of their bond angles. Like that they will ask you. They will not give the hybridization, they will not give any other thing. So like this we can easily identify the hybridization of any molecule. If they give you I3 minus, let us see. I3 minus, all three atoms are same, so you take only one as the central atom. So that's why half into 7 plus 2 iodines are there. 7 plus 2 plus 1 by 2. So it will be 5, and the hybridization is sp3d. Why plus 1? Since there is a negative charge is there, we will add it to that one. So that's why it will be 7 2 plus 1 by 2 equals to 5. Like this, we can understand the hybridization of the any inorganic complex or any inorganic molecule. We can easily identify. Sir, how to identify the hybridization of the complex molecules? How to identify the hybridization for inner orbital complexes, and how to identify for outer orbital complexes? What are the different complex questions they can ask you? That we will do in the hybridization part 2. In the part 2, and we will be focusing on the advanced problems on hybridization also, and how to solve them also. We will be discussing number of ways of asking questions will be there based on this hybridization. In hybridization part 2, I will be explaining all those things. Right, and that is for this video, man. And if you like this video, like this button. You want to share with your friends, means share the video. And you want to get more notifications from my channel, means click the subscribe button and click the bell icon for the notifications. Yeah. Thank you.